Hi, my name is V, and I'm an electrical engineer, which means that I love science and physics and all that kind of stuff. And today I would like to explain to you guys the application of the double slit experiment that you may have learned in physics and have learned probably multiple times and have had it engraved in your mind. Basically, what the double slit experiment is saying is that light not only behaves like a particle, but also like a wave. And it does so in such a way where when you observe it in the experiments, it reacts a certain way. But then when you don't observe it, it reacts a different way. And that is because the effect that the observer has on the experiment by observing it. Isn't that amazing? So that proves that light is both a particle and a wave at the same time, which is an impossible duality, but it does it anyways. So let me show you how this is applied to real life, and you can actually see it in person, and you can actually apply it to real things in your real life existence. Now, right here, I have a red heat shrink, okay, tubing, right? Now, the experiment is I'm going to drop it into this clear cup, right? And when I drop it in there, we're going to see what happens to it. Okay, it was red when I dropped it. It's red now in the cup. Let's try that again. It's red and it's red. Okay, let's try one more time. It's red and it's red. Now what we're going to do is we're going to conduct the experiment without the effect of us observing it, thus changing the results. Now, so I'm going to move the experiment over here to this side, okay? And as you can tell, I'm looking at you. I'm not looking at the experiment. And I'm going to drop the red heat shrink tubing into the cup. And now that we didn't observe it, let's see the results. Oh my God. Oh wow. It's black. So wait, what happens when we drop the black one into the cup and we observe it? It remains black. It remains black. It remains black. Okay, now let's conduct this experiment without observing it. Okay, I'm going to drop the black heat shrink tubing into the cup, and let's see what the results are. Oh my God, it turned red. Wow, so when we observe it, it seems that the heat shrink tubing stays the same color. But when we don't observe it, it somehow changes from red to black or black to red. So this can only mean one thing, and that is that this red heat shrink tubing, as we all would think it's just red, is actually red and black at the same time. Isn't that amazing? That's how amazing science is. This red heat shrink tubing is actually red and black at the same time, and that's what makes heat shrink tubing such a remarkable material. Because at first you would have just thought this was only red, but no, you'd be wrong, because this is actually red and black at the same time and becomes black only when we don't affect the experiments by observing it, which I would always think that observing an experiment would be the crucial deciding factor of the experiment. In fact, I personally don't think that any experiment that you're conducting that you're not observing, I feel like is not you conducting an experiment. But what do I know, right? I'm just an electrical engineer. But the double slit experiment has shown and proven that this red heat shrink tubing is red and black at the same time. Isn't that amazing? All right. And now you know.